students, welcome to Mathgotserved.com. In this clip, we're going to be taking a look at an example on transformation of triangles in the context of reflections and rotations. The question reads, on the set of axes below, triangle LET and triangle L double prime, E double prime, T double prime are graphed in the coordinate plane where triangle LET is congruent to triangle L double prime, E double prime, T double prime. Question, which sequence of rigid motions maps triangle LET to triangle L double prime, E double prime, T double prime? So one thing that can help us to narrow down our options, alternatives, is to take a look at the orientation of the original compared to the image, okay? So if we take a look at the original triangle LET, if we go, let's say we're going in the clockwise rotation, all right? Going in a clockwise rotation, we have LET, all right? Now let's take a look at the image. So we have LET. Let's take a look at the image and go in the same orientation, okay? Starting from L, if we go clockwise, starting from L, we have L double prime, T double prime, E double prime. So you notice that the orientation is not preserved, okay? So let's write that down. Orientation is not preserved in this transformation. Okay. And then something that you want to keep in mind is that whenever you have translations, dilations, or rotations, the orientation is always preserved. Okay, something to note is that orientation is always preserved under dilation, translation, just like a shift, and rotation. Okay, it's not preserved under reflection. So if you take a look at this question, we notice that the orientation is not preserved. So that tells us for sure that a reflection must be a component of this transformation that we have here. Okay, so in this particular question, let's write that down. Since the orientation is not preserved, then we know that then a reflection must be a part of the transformation. Okay, all right, so if you take a look at the options right here, number one is strictly reflections. Okay, so that's a possibility. It could be number one. Number two is strictly a rotation, so it can be number two, because if it were just a rotation, the orientation will be preserved. Okay, number three is a rotation and then a reflection. A reflection is part of it, so it could be three. And then number four is a reflection and a rotation. So it could be either option 1, 3, and 4. We're going to take a look at all of them, okay? So the first one says a reflection over the y-axis followed by a reflection over the x-axis. So let's just sketch them out. So number one, if you do a reflection over the y-axis, you see y-axis right here, it's just going to flip to the right, right? So you have a point right here, up 3 over 2, up 3 over 2, bam. and then down 2, back up 1, 2, 3, 4. All right, so this is a reflection across the y-axis, E prime, L prime. It's just a rough sketch, so part of my sketch, all right? And then reflection over the x-axis, if reflected over the x-axis, you're going to have, this one is going to go straight down, up 3, down 3, 1, 2, 3, bam. Down 1, bam. And then this one, go up 1, 2, 3, 4, 5, 6. So you're just flipping it down, right? 1, 2, 3, 4, 5, 6. Okay, so this is L double, T double, and E double. Bam. So this would be the resulting shape right here. That's the sketch. So we can clearly see that it is not option 1 because the resulting figure doesn't overlap this one perfectly. Okay. All right, so now let's take a look at, or we can skip, well, let's just look at option 2. We know it cannot be option 2, okay, because the orientation is not preserved here. So let's just take a look at this. What will it look like if we rotate this triangle 180 degrees? The direction doesn't matter because if you rotate 180, either clockwise or counter is going to be exactly the same thing, right? So one way to help you visualize rotation is by actually physically rotating your paper, okay? So this is going to be a 180 degrees rotation. If you do that, top goes to bottom, bottom goes to top. So a 180 degree rotation is going to look something like this. Bam. You see how it is? That's what a rotation is. And you see how the orientation is still preserved? Okay. So let me go ahead and sketch it for you. If you do a 180 degree rotation, this point right here, up 3 over 1, you're going to go down 3 over 1. This point will be point E double prime. You see that? And then this one from the E point, 1, 2, 3 over 1, 2, 3. So you're going to go down 1, 2, 3 over 1, 2, 3. Okay, that's L double. And then this one go down 1, 2 over 1, 2, 3, 4, 5. So you go up 1, 2. Right. 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, 5. Bam. All right. So this will be T double. And then this will be the final figure right here. Bam. You can clearly see that we don't have a complete overlap. So option 2 is clearly not the answer. All right. Okay, let's move on to the next one. Option 3. Option 3 is a rotation 90 degrees counterclockwise, followed by a reflection over the y-axis. All right, so let's go ahead and do that. So a 90 degrees counterclockwise rotation, an easy way to visualize that is that if you do a 90 degrees counterclockwise rotation, you're going to go rotate in this direction, right? 90 degrees. Basically, this one right here, you see how this is the y? This y, positive y, is going to become negative x. It's going to end up here. And then your negative x is going to end up here. Okay? So this entire figure is going to end up somewhere around here. So like we indicated earlier, an easy way to visualize a rotation is by actually physically rotating your notebook. So we're going to do that right now. So 90 degree rotation counterclockwise, quarter of a circle rotation like this. Bam. That's what it's going to look like. You see that? It's going to look something like that. So let's go ahead and carry out that transformation. We're going to do the 90 degree rotation first, and then we will do the reflection. All right, so we'll do the 90 degree rotation. This point right here, up 1, 2, 3 over 1 is going to go to the side 1, 2, 3, down 1, bam. That's going to be E prime. Okay, this one you are going 1, 2, 3, 4, 5 and up 1. Starting from here, you're going to go down 1, 2, 3, 4, 5 and over 1. This is where t prime is going to be. And then from this one right here, we're gonna go up 1, 2, 3, 4, 5, 6. 1, 2, 3. Starting from here, 1, 2, 3, 4, 5, 6. 1, 2, 3. Bam. All right, so this will be L prime right here. And you can connect the dots. Let's use a ruler to connect the dots for the first transformation. Okay, so it's gonna look something like this. Oh snap! There's the arrow. Let's use an actual ruler here. Blurring one. Okay, so this one right here. Bam! See that? To there. To them. To them. Bam! So that goes. This is just after a 90 degrees counterclockwise rotation. All right, and then the last transformation that we're going to do is a reflection over the y-axis. Okay, so if you carry reflection over the y-axis, this one goes 1, 2, 3 to the left, so a mirror over the y-axis, so you're gonna go 1, 2, 3 to the right. Bam, jackpot. You see that? It lands perfectly. E lands perfectly on E double. And then this one, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. The same direction over the y-axis. Excellent job. We have a match there. Okay, and then you do the T transformation. Let's move the L closer. 1 to the left, 1 to the right. Reflection across the y-axis, and you see the perfect overlap right here. So question option number 3 is the correct answer. All right. Thanks so much for taking the time to watch this presentation. I really appreciate all who have been supporting our channel with likes and comments and subscriptions. Tons of support resources can be found on Mathgotserved.com or the links in the description below. If you have any questions, comments, special requests, or you just want to let us know how your day is going, specify it in the comment section below. Thanks again for watching. We'll see you in the next video. Goodbye.